Hi, my presentation is on refactoring. My name is Sam Taggart. I am a certified LabVIEW architect, professional instructor, LabVIEW champion. I'm also part of Fabiola's DQMH Trusted Advisors program. Is that loud enough? Can everybody hear me? What? Good, bad. And I run a small company called System Automation Solutions, LLC. We used to do what I would call firefighting. So people would come to us with problems, and we come in and put out the fires. And we're trying to move more into teaching fire prevention. So we're trying to teach small groups how to use source code control, issue tracking, unit testing, and how to integrate all of that. So if that sounds interesting, we should talk afterwards. All right. So I saw Fabiola's post a long time ago, and I thought, well, I like Fabiola, and I can do that. So I picked Barbara Liskov. I went through all the lists Fabiola put out there and stuff, and I tried to find one that had some connection, so rather than just randomly pick some woman. And so she was one of the first women to get a PhD in computer science from Stanford way back, I think, 70s. You've probably heard of her because you've probably heard of the Liskov substitution principle, which is part of the solid principles. If you've listened, Alan talks about it, John McBee. So if you read the book that came from, Uncle Bob's book, it clearly mentions Barbara Liskov. But when you hear McBee and everybody else mention it, they just say the Liskov principle. And dumb me, I thought old Russian guy with gray hair. So I was quite surprised.
Dmitri talks about her all the time.
Well, yes, that too. I also heard from Dmitri, and the name's Liskov. It sounds very Russian. Sorry if anyone here is Russian. But so I was pleasantly surprised. So. And back in the day, she did a bunch of work on AI stuff for chess. But right now, she's head of the programming methodology group at MIT. So obviously, she's pretty smart. And they're working on something called the Byzantine general problem. So if you know anything about Bitcoin, it's a networking thing where when you got a bunch of things on the network, trying to figure out which one's correct, that's called the Byzantine general problem. You can go do a bunch of research on that if you want. All right, so I view this as a conversation. Obviously, it's very one-sided at the moment, but you can feel free to ask questions. And if you want to connect with me on LinkedIn or send me an email or anything afterwards, I'd love to talk with you guys. And if you really want to talk to me, just buy me a beer afterwards, and I'll talk about whatever you want. Okay, so let's do a little exercise. When I say refactoring, what do you guys think of? Anybody? Come on, somebody's got to have something. We know, okay. So
Improving.
What?
Improving.
Improving, okay. So I know you guys.
Somebody who's failed the job interview on the code test.
Oh.
I think of Fabiola's green and red cards from the CNLA Summit.
Yes, I do remember that exercise. Okay, so I know you guys can count, but refactoring is not a four-letter word. Right? Because I used to associate with four-letter words because I always associate with this. And the first thing out of my mouth when I see that is usually a four-letter word. And usually it's followed by, we want you to fix this or refactor this, right?
I think that must be the most famous book, though.
That's not this presentation. So this presentation is not about fixing this. If that's your problem, you should probably talk to Fabiola, because she seems to like fixing these things. In fact, she even had a presentation about it called Finding the Meatballs in the Spaghetti.
Yes.
So that will help you with that. But if it's not about fixing spaghetti code, what it is about? Well, it's about how we develop software to begin with, right, when we're doing our design. And we face this little dilemma. We kind of get pulled in two separate directions. On one side, we have the guys who are preaching s'mores, scalable, modular, optimized, reusable, extensible. There's a reason simple's at the end, because everybody focuses on the other one and completely forgets about that one. Because if you do all the others, it's probably not too simple. But you got those guys, and then on the other side, you got the guys who say you ain't gonna need it, right? So s'mores guys say, design all this stuff in up front, and the other guys say, well, yeah, but that's a lot of work, and then you gotta maintain and test all that code, and it's a waste of time. And you can go to the extreme on either side of this, right? You can become an architecture astronaut, right? Anybody met one of those? Right? So these guys design code, It's not spaghetti code like that. All the lines are nice and straight, but you have to click through 29 layers of dynamic dispatch to find a VI that actually does anything. And then the other side, you got the spaghetti coders, or I call the get her done guys. They just want to get it done, and it has to work, and that's it. And they don't care what it looks like or how pretty it is, right? So the trick is we want to stay in the middle, but we feel like we got to make a choice, right? But it's a false choice, right? You can have your cake and eat it too, just like that little kid up there. So how do we walk the line and stay in the middle and not veer too far off either way? Well, the first thing I'm going to suggest, and this is what I do, so it's not the only way to do it, but this is my philosophy. Start with a framework. Whether it's Actor Framework, EQMH, Decaf, if you happen to like one of the other ones, that's fine. The framework gives you some structure. It gives you some flexibility, right? There are some bounds, but it's pretty easy to add another module if you need something else. And all the Yagni guys will say, oh, but you're adding all this complexity, and that's true, but anybody who understands the framework will hopefully not get confused by that complexity, and you don't have to test it, right? You're not writing extra code for those extra functions. You just don't use them. So that kind of keeps both sides happy. Hello? Yes? Okay. And then the next thing, so you pick a framework that you think will work, and you lay out your modules, and don't obsess about it and try to get everything perfect, because you won't. And even if you do, the requirements will change, or something will happen, and it won't be perfect, and it'll need changed anyway. And then just start coding. Once you have your modules laid out kind of well, and you think it'll work, just start coding. And you say, well, what if I run into problems, something doesn't work? This is where we're going to refactor, right? So refactor very liberal as you need. So we're not adding in any extra functionality until we need it, and then we're refactoring. And when we do, we're going to use design patterns. Right? So if you've got something that kind of looks like one of those design patterns, use the design pattern. It will definitely help everyone else understand your code, and also help add some flexibility, because that's what they're designed to do. All right, so I call this whole process continuous refactoring. It involves killing a couple sacred cows. So the first one is, some of us have this idea that we have to get everything right up front, right? That our design has to be perfect and all that. And again, as I said, it never is, right? And the other one is, sometimes people get really proud of what they wrote. They wrote something and it's worked for so long, and then they have this use case where they need to make some changes and they don't want to. Don't be afraid. If you need to refactor something you wrote a long time ago, refactor it. Even if you wrote it yesterday, and refactor it if it needs it. All right, so what do you get out of this? Well, you get faster turnaround time, right? Because we're starting with the framework and we're not over-designing it. We're not spending as much time during design. We're writing less code because we're using the framework, and because we're not adding a bunch of features that we don't need. And because of that, we have less code to test and debug, and that makes our code more robust. Right? But we stay flexible because we're using a framework. It's very easy to add extra modules, and if we need to refactor, we can refactor into design patterns, and that lets us add some flexibility. All right, so that's pretty much like the thesis of my whole presentation. That's where we're going. How do we get there? We're going to talk about some refactoring basics. And then we're going to talk about a few tools that you already use that are refactoring tools that you probably don't even think about. And then we're going to walk through an example of how refactoring fits into the process. And why did my computer just do that? Hey, all right. And last, I'm going to go through, why didn't I like that slide? Oh. All right, lastly, lastly, if this works, we'll go through some caveats. All right, so here's a reading list. This refactoring book is actually what prompted this whole presentation. I had a project where somebody handed me a mess of spaghetti code, and I thought, oh, yeah, I'm going to have to refactor this. So I read that book, and then I didn't get the job, but at least I got a good presentation out of it. So the book's very good. It goes through a bunch of different example refactorings. Unfortunately, they're all in Java. I don't speak Java, which is why I have the UML book up there, because he's really good about drawing UML diagrams, and that makes it very easy to understand. So if you haven't read the UML book or you don't know about UML, that's a very good place to start. And the design patterns book is very useful because when you're refactoring, it's good to have a plan, and your plan should be to get into one of those design patterns if you can. Anybody read any of those books? I know Alan, Gang of Four probably, right? Everybody's read that. Lots of people. The UML, yeah. There is another UML book that I've seen recommended, but I don't remember what it is.
But this is the one that has on the front page and the end of the page, like the summary of all.
Yeah, that's like 99% of what you need.
Yes,
If
exactly.
you just photocopy that, you'd be pretty good. All right. Oh, and so all the refactoring examples are in Java, so not all of them translate to LabVIEW, because some of them have to do with how they handle references and pointers and stuff. But 99% of them transfer over pretty easily. So, all right. So refactoring basics. Right. The secret to becoming a master is to master the basics. The best person for that is Steve Watts. If you haven't seen his presentations, you should go watch one. It's very good. He just stills it down. So I used to do judo, and I did judo for like 6 years. And the first anybody else do judo ever? Like the first 6 months, all you do is literally fall. They don't do anything, they just fall, right? And so you think if you go into like a black belt class, you think they'd be doing all kinds of advanced throws and flips and stuff. First 10 minutes, all they do is fall, right? It's that basic. So the stuff that we're gonna talk about here is basic, but it's very important. All right, so while we're talking about basics, this struck me as very basic, but I never really thought about it until I read that book. So all code is written for two audiences. Anyone want to take a guess what the two audiences are?
The computer, the machine,
Yes.
and other programmers.
Did you read that book?
No, I read
Okay.
that in another book. I can't
Okay, well, doesn't matter. It's very true, right? So you're writing the code for the compiler so it can tell the computer chip to do whatever it's going to do. But it doesn't care if what you're doing makes any sense at all. You can write really crazy LabVIEW code that does nothing useful, and it will compile and run, right? But the more important part is human beings, right? Me, you, whoever else looks at your code next, right? So as Fabiola likes to say, be kind to your future self. Even if nobody else is going to look at it, you're going to look at it again someday. And it'd be nice if you remembered what you were doing. Right, so we've been talking about refactoring. We haven't really defined it. I would say refactoring is writing code for that second audience, for the human being. Right? And so it's the process of changing a software system in such a way that it does not alter the external behavior, but improves its internal structure. So we're making it better, but we're not actually adding any functionality. We're making it easier to understand and read. If you're adding functionality, that's not refactoring. It's related, but not the same thing. So basically, to use a non-LabVIEW example, it's kind of LabVIEW-like actually, right? Imagine if you start out with something like that as a circuit, and then replace it with a nice printed circuit board like that, right? That's basically what we're doing. Those two circuits do exactly the same thing. The one on the right is much easier to debug than the one on the left. It might as well be LabVIEW code, right? You could have spaghetti pile on the left and same thing. What was it? Okay, yeah, I just pulled that off the internet somewhere. Sure.
It must have been in a very dusty corner of the internet.
All right, but you guys say, well, oh, I'm going from this, rat's nest to that nice circuit board, but what if I get it wrong? What if I break something, right? Well, we got a couple tools to help us. So if you don't recognize the two icons, the one on the left is the icon for get, right, which is source code control. And you can use Subversion or Perforce, whatever your favorite flavor is. And so every time we make a change, we're going to check it in there after we run our unit test. So we make a change, we test it, and then we check it in. So basically this triangle diagram here is what we're going to do, right? And it's cyclical. And as you get better at refactoring, you make more and more changes between each cycle. But generally, small changes are good, because if you make a mistake, you can immediately roll it back. And you know exactly which tiny thing you did that broke it. Right? And so the first step is, it helps when you start with code that actually works. Right? If it doesn't work, it's not really refactoring, it's more like bug fixing. And then, if you don't have tests, create some tests. And then you just get into this cycle until you end up where you want to be. Any questions? Yes?
I was taught many years ago the idea of refactoring started with shift-delete. You keep all the documentation about what it is you're trying to achieve in there,
Okay.
and all the inputs and outputs. Sorry. I was taught many years ago the idea of refactoring involves shift-delete. So you keep the documentation about what it is that you wanted the thing to do, and all the unit tests that would go around it and all the inputs and outputs. But by starting over again, you didn't make inconsequential small changes. How do you balance between the two options of doing it?
So you're saying keep all the black box inputs, outputs the same and just throw everything away inside?
Yeah.
That's quite possible. So how big these small changes are depends on how much work you want to lose, right? So if your small change takes you an hour, okay, if you're okay with losing an hour, then make an hour. If you don't want to lose an hour, work for 15, 20 minutes till you get something workable, test it, and keep going. So,
Probably invert the two first tests as well.
inverse what?
Create tests before starting code.
Yes. Okay, yeah, so he's talking about test-driven development, and that's also a very good idea. But if you get code that does not have tests, the first thing you should do is create a test. So, because this doesn't really work if you don't have anything to test, because you're just small change, commit, and then at the end, you're like, it doesn't work. Well, which change do you undo? And then you got to figure that out. In which case, you got to write a test to figure it out anyway. So you might as well start that way. Any other questions? So when do you refactor? I like to refactor continuously. I think of it as like dusting, taking out the garbage, doing the dishes. If I'm working on code and I see something like an indicator or control that needs renamed or a VI that needs renamed, I just do it, generally. It works well if somebody hands you some spaghetti code and you can't figure out what it does. You can start by doing some small refactorings to try to sort it out. The big one, I use it a lot, is when you're preparing to add a new feature. And Kent Beck, who wrote Extreme Programming, has a very good quote. For each desired change, make the change easy. Right? And he says, warning, this may be the hard part. Then make the easy change. So making the change easy means refactor your code so that then, in order to add the feature, all you have to do is add one little VI or one tiny case structure, and away you go. The only other thing I'm going to say about basics is begin with the end in mind. Right? Don't paint yourself into a corner. Right? If you're going to refactor, don't just go and start making random changes. Have a plan, and generally that starts with one of the design patterns. Right? So pick a design pattern that you think you're going to try to end up with, and start moving in that direction. How much time do I got left? Okay. Yes, Darren.
Yeah, so when you're doing your refactoring, if you're doing refactoring to then add functionality to it afterwards, do you refactor exactly what you have now to get and make sure that works and then add the functionality, or do you add the functionality while you're doing the refactoring?
I think part of it depends on how big of a change it is, but generally I would say change the code first, what you have, and test it, and then add the new functionality. That would be my recommendation for any significant change. If it's a really tiny change, maybe you just do it all at once and test it. Like if it takes like 10 or 15 minutes, then you lose 10 or 15 minutes if it doesn't work, and that's it. Yes, Fabiola.
So I think that the very first thing is to make sure that when you're refactoring, if it's not your code, the very first thing is to make sure that it still runs.
Yes.
And it still does what they think it does.
Well, that's the problem.
Yeah, and then you start adding stuff. If it's your code, you still need to start making sure that it still does what you thought it was doing, and that's when having unit tests and making sure the test pass is a good idea.
Yes, Steve.
You've missed out. You've missed out one between block diagram cleanup and renaming. There should be one which is undo block diagram cleanup.
I didn't say it always worked. I said it's a refactoring tool. So the one nice thing about refactoring tools is they go both ways. So cleaning up the block diagram is refactoring, and so is making it all messy again. So.
Yeah, you just can select a little section, you know that, right? Okay.
So just out of curiosity, how many people actually use unit testing? How many people test their code? Who was on earlier that said if you put them in an elevator and ask them, they kind of back down, ask that? Anybody? Right, wasn't that one of the presenters earlier? Okay, so here are some tools that you already use that are refactoring tools, right? Steve mentioned block diagram cleanup, right? Hopefully, it's designed to take that spaghetti mess and turn it into that nice printed circuit board. Doesn't really do that, but gigantic printed circuit board, maybe. Renaming controls, indicators, right? How many people ever write a VI and then the purpose of it changes or it starts doing more things and you end up renaming it, right? Do that and rename it. Don't leave the old name. Create sub-VI. Anybody ever use insert sub-VI contents? I've actually found myself using that a few times lately, believe it or not. So that's a handy little one sometimes. Create object from cluster. I don't know if anybody remembers that. That came out when classes first came out, but it's also still useful. Somebody who maybe doesn't know about object-oriented code and has type-def clusters everywhere, you can right-click on them in the project and convert it to a class. And then you'll have to go clean up a bunch of stuff, but it's a useful refactoring tool. The active framework of DQMH rescripting tools. Some of the functions on there could be considered refactoring, like renaming messages and stuff. Anybody else have any other ones that they use that are built into LabVIEW? Did I miss any? Yes?
I think using diagram disable structure is very useful.
Yeah, I think one really important thing is to use diagram disable, because then you can really easily swap between the implementations and when you run tests. I use tests all the time.
Yeah, actually, that is a very interesting way of doing it. So instead of using source code control to keep your copy, you just disable the code that you're replacing, write the new stuff, and then run it.
Not instead.
Well, in addition, yes, absolutely. You should still be using source code control, but if you do that, maybe you don't need to check in every little change.
It's a temporary during
Temporary, yes. So it makes it easier to switch back than to go back to your source code control and check it out again. And I could see where that would be useful because depending on what you're doing, right, LabVIEW having classes open and stuff and then having to exit LabVIEW and load it back up, right, that would be a pain. Anything else? Anybody else have any other tools they use?
We tend to be using the sub-diagram labels and constant labels and things like that. So we would go through code, labeling things, giving them their labels. So if you've got case structures, doing what the case logic is and all that kind of stuff. And we would do that obsessively in a refactoring exercise.
That's very interesting. I think that's a great idea. The refactoring book, makes the point that if you've got tons of comment in a chunk of code, then that's a good candidate for a sub-VI or a function, perhaps.
Yeah, it's not commenting the code, it's actually labeling the code.
Different. Yeah, okay, yeah.
I'm not into commenting code.
Yeah, okay, good. No, very good distinction.
What is the insert sub-VI content?
It basically does the opposite of create sub-VI. So you have a VI that maybe for whatever reason you don't want it to be a sub-VI. It basically just inlines it, but it's similar to inlining, except it just drops it on the block diagram. Sometimes that's useful, like if you have two sub-VIs and maybe you want to pull part out of each one and make a third one, then you can use that and then pull together the code you want for the third one. It's not super useful, but I have found a use case for it. So if you ever need it, it's there. Any other stuff that I missed? Yes?
I was wondering whether you think code reviews are a sort of supporting tool for refactoring.
Code review might lead to refactoring. If somebody's like, what the heck are you doing over there? Decide that maybe you need to refactor it. I mean, I guess part of it might be how many questions do you get, right? If your code review, if you're getting 50 million questions about what the code does, it's probably not well written. Probably could use some refactoring. Other questions? All right, so we're going to go through an example. How much time do I got? Oh, I got tons of time. All right, so let's say that a customer has Agilent DMM, and they need to take some tests, some measurements, and they're going to collect the average. And let's just say maybe even you wrote this code, right? Because if a customer comes to you and they've got one Agilent DMM and they need to take some measurements, how many people would actually take the time to write a whole HAL and everything for just that? Probably not, right? It's extra work. Right, so you got something simple like this that just calls the Agilent driver. The customer says, wow, that works great. I'd like to make another test station, but I don't have another Agilent. But I have this NI 4070 DMM that I want to use. Right, and they want to be able to support both. So if we start with the end in mind, I kind of already gave it away, but what design patterns does anybody think we're going to use? Right. I think Alan said it, hardware abstraction layer, right? And that's going to look like this, right? We're going to have some DMM parent class, and then we'll have our Agilent DMM and our NI DMM. Right? And so if we look at Kent Beck's advice, make the change easy, then make the easy change. If we change our code to instead call the parent class there, and we give it a child object, the Agilent DMM object, right? And replace all the calls to the Agilent driver with that. Then making the change for the 4070 is really easy because we just create a child class for the 4070 and we add it to a factory that produces either a Agilent or 4070 and we're done. Right, so replacing the current calls with the class-based calls is the refactoring step. And actually, let me jump ahead. Right? So basically, we would take that up there and replace it with this down here. And each of those VIs just wraps the driver for the Agilent DMM. Right, so that's our refactoring step. But before we get there, right, the customer tells you, oh, the current code works, right? And it's in source code control. But we have both DMMs and a power supply and a function generator. What do you think we ought to do? Fabiola? Test it, right? We should hook it up and run some kind of test, right? And we're going to verify before we start. And then every time we make a couple changes, then we're going to verify it again. In this case, we're not really unit testing because we got hardware, but it's easy enough. Turn it on, set the power supply to some value, take a reading, make sure they match. So the basic steps, right? The first thing we're going to do is we're going to create a parent class, our factory VI, and our general class hierarchy. And we can do that without touching the existing code at all. And we can even fill in the class methods for the Agilent DMM, and we can test that. And we still haven't touched our original code. It's still pristine the way they gave it to us. And then step 3 is really the refactoring step where we take all the calls to the original DMM driver and we replace it with our class-based code. And then we test it. And that's the refactoring. So now we've made the change easy. And we're making the easy change by creating a new 4070 DMM class outside our program. We can test that. And then all we have to do is change our factory VI so it can output either a 4070 object or an Agilent object based off of an INI file key or some button on the front panel or whatever we want. Is that kind of clear? So eventually we do this, and then the final product would just be that Agilent object replaced with a factory VI that outputs either an Agilent DMM or a 4070. Anyone have any questions? All right. Sorry, yeah.
I'm not aware of any, I'm sure if you are. You spoke about kind of refactoring on a VI level. Are there any tools for refactoring at a class level, so like pulling out the parent class?
So I don't know of any tools to actually repeat your question so it gets it on the board.
I thought I got away with that.
It was a good question.
So we spoke a lot about kind of tools in a VI. Are you aware of any tools for doing stuff with like classes with refactoring? So like one I can think of, which I think is in the book, the refactoring book, is extracting a parent class. So if you had the Agilent DMM and you wanted to create the abstract parent, I've never seen any, and I'm curious if, but maybe they exist and I've never.
I've never seen them either. I thought about doing that as the example instead of starting with the original calls, and I was going to say copy the class and then just strip out all the methods, and that's your parent class. That would have been my thought. Maybe there is. Yes? Way back in the back.
I think OpenGDS has a tool for that.
It does? Oh, cool. Does it do any other class-based refactorings or like moving fields around and perfect data?
The way I've done it was
here.
The way I've done it is because you can do the reverse engineering for the UML, you can then just copy the box of the UML with all the labels, and then it generates the class for you.
Oh, okay.
So But I don't know, there has to be something, because there's several menus, so I don't know if Danny, was that Danny? That said it?
Yes. As addition on that, there's a tool in the project provider which is generating from a specific class the abstract class. You can just do it with the right click and say generate an abstract class from this child or for this child. And
Really?
OpenGDS.
Oh, in GDS. Okay.
Open GOOP Development Suite.
So as James pointed out, there's a whole bunch of object-oriented based refactorings in there, like moving fields from child classes up to parent classes, and there's several other ones. Any more questions about that before we get into the caveats? Anybody do a lot of object-oriented refactoring, like moving stuff around? Yeah, some. Looks like you try to avoid it, just based on your face. Okay. Yeah, that's kind of what I found.
But I'm with you. It needs to be done. When it needs to be done, it needs to be done.
Mm-hmm. Yeah. So don't let pain stop you from refactoring, because I guarantee it's almost always more painful if you don't refactor. All right, so some things to be careful about. You got to watch changing API methods on released code. So the best example of this I can come up with is the actor framework. The old launch actor, right? They kept it around, so it didn't break any existing code, but they very clearly marked it as deprecated and removed it from the palette and replaced it with the new method that you're supposed to use. So if you just get rid of it, then anyone that used the previous version will now be broken if they upgrade.
Well, the old is still useful.
Yeah, and it is still useful too. So, and that also speaks to very liberal use of privacy settings in classes and libraries. I like the fact in the DQMH that everything but the API is marked private. That's the way it should always be. In fact, I would like to see the default for all new methods inside a class or in a library to be private. That you have to explicitly make it public. I don't know if anybody from NI is listening, but that would be pretty awesome. I had another resource here. I thought I had 2 pages. Oh, I got past. Oh, the other caveat, changing control indicators and names. You have to watch out sometimes if you're using VI server stuff or scripting. You can mess with some of that stuff. And moving or renaming stuff on disk. I'm sure you guys all know, but you got to make sure you have it loaded in the project, right? So it'll fix all the linking for you. Yeah.
It's not only for scripting, it's if you're doing control value get and control value set. You also need to be careful with the renaming.
Yeah. Yep. You want to repeat that, actually? I don't think that got it.
If you are using control value set and control value get, that's specifically the one that gets you when you rename controls.
Okay. And the other one is to be careful with reuse code, right? Because it's impossible to make sure you have all the callers loaded into memory if you're renaming stuff. That's why somebody mentioned earlier the idea of using VI packages to distribute code. That's why I like them. Because you have a release set and that's it.
The other place where renaming gets you, it's on testnet.
Oh, I can see that.
The other place where renaming gets you is in testnet, because if the prototype of the step you're calling changes, and the change in a terminal name counts as a prototype change.
Okay. Anyone else have any problems refactoring stuff? Like Alan said about classes, right? You got the problem of stuff going out of classes not going out of memory, which can cause problems.
Yeah, I've generally found that if I have to rename something in, usually a class or a class in a library, that I will wind up using either a scratch project, or I tend to have sub-projects anyway because it makes testing easier. But if you've got your full-on project with your classes that are calling each other and you have the sort of typical arrangement that you have in a large class-based system, it can be, I don't think I can say an adjective strong enough in this room being recorded for just how difficult that can be. So I will often have smaller projects, or I will pull up just the library itself and I will make the changes, and then I kind of have to step back up into my main project and sort of eat the changes, but that breaks them up and it makes it easier for the compiler to manage.
Yeah, well, I've wrote some little tools for like if you change the name of a class to go through all the member VIs and change the name of all the inputs, because that's kind of a pain, you know. You have like a device, a DMM, and you copy it, and you want to make a, I don't know, a scope module, and they all say DMM in. It's like a... What? Is there? Oh, all right. Well, that probably would have saved me from inventing it myself.
I need to find that.
Yeah. Yes. All right, we have 10 minutes. We can be done, or people can ask questions or make comments. Yes.
Another thing that I tend to struggle with that example of the 4070 versus an Agilent one, my normal reaction is to go and reach something that already exists like IVI, but then you get caught out at the next stage. Where does your kind of thoughts go on how far ahead you're thinking with refactoring?
That's very interesting. I'm sure opinions differ on that. I tend to err on the side of if I'm not getting paid to do it, I'm not going to do it. It's extra work and effort, so if they want to pay me to do it, I'll gladly do it. But I mean, that might change depending on if you're a contractor or what. But as a contractor, yeah, you get paid to do a certain thing. That's all I'm doing. James.
Kind of a comment to that. I think what's really valuable with the way that you've put this across is you want to think ahead, but you also don't want to prematurely optimize things. And that's where this is really good, is you can save that optimization until you know, because I tend to find that, especially the class-based stuff, you can kind of make it expandable in one direction. And if you prematurely make it expandable this way, and then later you find it need to go this way, it's actually harder to fix. And that's where you want to think those couple of steps ahead, but that's the risk, I guess, if you make a double jump, in my experience.
Well, I think part of the trick is getting really good at doing these refactorings so that then you can just do them on demand.
Yeah.
That would be like the ideal. I mean, the class-based stuff is really hard, so that it's almost worth thinking further ahead like that. But for other stuff, definitely like just knowing that you can make the change, like, okay, if I need to add a hardware abstraction layer to that first VI, I know it's not going to be that hard, so I'm not going to bother with it now. And then you're only adding stuff when you need it. Any other questions, comments? Yes.
With your hardware extraction layer, the problem is if you've not put that in the first place, but you've got a very, very complicated test scenario, that simple change in your example could ripple impact throughout your project. So if you've not planned for multiple power supplies or DMMs in, you know, your example is lovely and simplified, obviously, but the impact of putting that class in could ripple across a very large extent of your project.
Yeah, that would be the part where making the change easy is the hard part. Yes.
So, I mean, to that is what I was talking about earlier about what you said, that presentation where I talked about finding the meatballs in the spaghetti code.
Yes.
The problem there is not that you're making the change on the class or adding a hardware abstraction layer, is that the problem he's describing is you first need to find all the meatballs, all the places where the data acquisition or the measurement control is happening, abstract that into a class or sub-VIs or whatever, so turn it into meatballs, and then you can go ahead and apply the change you're saying.
Yeah, I think if you're using your DMM in that many places, maybe you have a problem with your modularity.
Yeah, that's it. You have a spaghetti sauce and not meatballs, and you really need to get all those little pieces of the spaghetti sauce into the meatballs.
Yeah.
I think a good way to do that is to force to break your code, so then it's easy to find where it's broken.
That's why I like the convert contents of cluster to class. It's very nice. Actually, and that might be a solution to your problem. If you're passing around that ref num for the DMM, if that's a type def, you can then just do that.
But if you are using HAL abstraction, you're putting an abstract on top, you're not really breaking what you said on the first slide from Martin Fowler, that you're actually changing the interface then. It's not true refactoring, you are actually changing the interface. It's not unmodified.
Hold on, let me go back to that real quick. And I think it depends on what level you're looking at modifying, right? Where are you drawing the boundary? Right? So you're not altering the external behavior. External to what? Right? Where are you drawing your black box? Right? You're changing the interface between several classes or several objects inside your program, but from the outside world, the functionality is not changing. Does that make sense? Potentially, if you're sharing that somewhere else, but if it's truly encapsulated, then, right?
I find the broken arrow very useful.
Steve always puts things so simply. All right, more questions? We got a couple more minutes.
You need to repeat that one for the back.
Oh, yeah, sorry. Steve said something about he found the run arrow.
Broken arrows would be very useful.
So the broken run arrow is very useful. All right, any more questions? Comments? How many people would say they actively do refactoring following that whole triangle diagram? And everybody else, you guys still refactor your code, you just don't follow the little diagram? How many people have ever went to change something in their code and then broken everything? Right? Yes, exactly.
Of the rest, of the ones who kept your hands down, how many of you relied?
All right.
I was going to add one other thing, and I think it was Justin Gores back in the day said even if he wasn't making a change or adding a feature, every 2 or 3 weeks he would shut off his phone and refactor for a day or so.
I think that's a very good thing. I think that's the dusting. Did I make a comment about that? Yeah, continuously, right? Like dusting, taking out the garbage, or doing. Generally, if I see something that just doesn't look right, that's got one of those code smells, and I can just refactor, I do. It helps when you're by yourself. You don't really have to coordinate anything. Just go do it. But if you work in a group, that might be a little harder. But any other comments? How much time we got left? I got 2 minutes, so.
To add to a comment that you made before regarding who pays for refactoring, I often try to convince the customer that he should pay for refactoring, of course up to a certain level, but ideally you make him understand that it's in its own interest to have you refactor for future maintainability, and maybe your business goes away, etc. And if it's refactored nicely, other consultants can jump
That's
in.
kind of a hard sell, but yes.
Yeah, but it works.
See, I've just found it's an easy sell that when they want to add some feature, I just build it into the price of the feature and don't even tell them, and it works out. Because often it's easier. You're going to spend less time if you refactor first and add the feature anyway than just adding the feature and kludging it on.
I mean, with the costing of a refactored, so if you go to a customer with your own code and you just say, can you pay me to refactor it?
It's like, yeah, why didn't you do a good job to begin with?
Why? did you not factor it properly in the first place?
That's where I was going. I was trying to be a little more polite.
But you can, I guess you can do it on other people's code.
It's kind of like when you go to Best Buy and you buy something, they immediately want to sell you a warranty. It's like, is it going to break?
You may do it on your own code to make it more accessible to the person that you're giving that code to. So if you've started with something that's more advanced than their learning is today, giving them something that's easier to get their head around can be a refactoring.
That is a very good point. How many people have ever written something really complicated and then learned that you could do it in like one step, but you did in like 20 steps? Those are worth replacing. Even if you don't have to touch it, replace it, because then you'll understand it later, instead of trying to figure out what those 20 steps were for. I think we're about out of time. All right. Thank you.